our source for JVM knowledge.
Welcome to my talk, Boosting Your Applications with Distributed Data and Datagrids, and distributed caches and datagrids. Thank you, Grid, for inviting me to come here and be here today. It's been a pleasure, really, to join this conference for the first time. So, in October 2008, I was preparing myself to move to Paris at the time where I live, and there were a bunch of guys working for JBoss that had this idea of doing cache implements concurrent map in Java, and so that's how Infinispan was born. And so 10 years after, we are now with the version 10, which is in beta 3, and it's known as a datagrid. It's an open source product, completely open source, Apache 2 license. And if you want support, it's Red Hat who is doing the support of datagrid. So who knows what a datagrid is here? Yeah, please raise your hands. It's important for me to know. Yeah, not much people. Who knows what a NoSQL store is? Yeah, everybody knows more or less what a NoSQL store is. So a datagrid is like a NoSQL store, but it's like something. Yeah, I'm going to present myself first. So I'm Katia, and Katia Aresti, and I'm working on the Infinispan team for 2 years now. And I'm a core developer of Infinispan. And what I've seen till now, it's most people don't know what datagrids are, so that's why I'm here, and it's something scares a little. So I'm working for Red Hat, and I love drama and acting, so I'm very happy to be on this room today. And you can follow me on Aresti, Twitter, and GitHub. So I'm a Harry Potter fan. And yeah, I forgot to say that I'm surrounded by guys at work, remotely, based in Paris, but I'm surrounded by women, little girls at home, and thanks to my husband that it's taking care of them in Paris now, so I can be here with you. And so, as a Harry Potter fan, who knows, who is a little familiar with the universe of Harry Potter here? Yeah, most people. So, for me, datagrid, as I said, is something like it scares a little, and I see it like if it's Severus Snape, right? Severus Snape is someone that you don't know if it's good or bad for you. You don't know if it's, you don't know much about, you're not sure about him, and in the end, you know it's good and it's super powerful. So, and it's like a NoSQL store, and there are a lot of features, but we're going to start from the beginning. So what's a cache? A cache, normally, it's something, it's a library you are going to embed in your application to speed up access to database, an external web service, or a calculation that it gets a lot of time to be done. So we are going to put it there, and so speed up your application, and it's data that it's in memory, right? So if you want, you can take Infinispan, which is like in the library mode, put it there in your application, and it will work like a local cache. But in general, what happens in production is we don't have only one application instance deployed, but we have maybe 3. So what happens when I have to deal with 3 different cases in 3 different instances? So what it happens is that maybe I'm going to put a value in Potter 1 application with my request, and request number 2 is going to land to Potter 2, and so the value is not there, so I have to recalculate and put it there. And what happens if then in Potter 1 application, the value is stale, so it's not valid anymore? How do I handle validation across all the nodes? So that's where Infinispan comes in. You can join this data, these 3 caches, 3 instances. So whenever someone is putting a value using a replicated cache, for example, so whenever someone puts a value in Potter 1, it will be automatically replicated to Potter 2 and Potter 3. If a value is removed it's the same if a value gets invalidated or an eviction is done or whatever. Everything is going to be propagated for you. So when a second request is coming to Potter 2, the values are there. That's nice, but if we have millions of data and, I don't know, more than 10 instances in productions, maybe it doesn't scale so much. So what is interesting is using a distributed data for that. It's distributed cache for that. So a distributed cache will behave exactly in this way. So if I put a value in Potter 1 with key Lumos, but I ask for this value from Potter 2 will know which instance ask to get this value, and I'm going to retrieve it. And so every node here, it's like I'm saying, use a distributed cache for my spells and have a one owner. In this case, what happens if I lose Potter 2 application? It goes down. I'm going potentially to lose 2 Inflatus spell. And yeah, maybe it's not a big deal because I can recalculate it and it's just my application is going to be a bit slower for a while. But what happens if it's shopping cart? What happens if I'm doing my online purchases, spending 30 minutes to put all my products of my supermarket products, and when I'm going to pay, Potter 2 application goes down and my shopping cart is lost. So I'm not very happy there after 30 minutes, and I'm not going to buy never again on this shopping online, and this is a true story that happened to me. So in that case, we want a little of redundancy. So what we can say is, instead of having one single owner for data, we're going to have 2. So if I lose one of the instances, I'm going to have a backup owner. And we can adjust this as we wish, as we need. What happens when another application comes and I'm going to do an scale up because I need more memory and I need more data to hold my production and my users? So what is going to happen is consistent hashing. It's going to work here. Who is familiar with consistent hashing here? Okay, so consistent hashing is the mechanism that allows, hashing is what allows nodes to know where the data is. It's like a hash map, right? You know, with the hashing, you know that even if I ask to Potter 2 for a key, it's going to find who in that moment, precise moment, has the value in the instance. But consistent hashing, what is very interesting and why it's very important is that when Potter 4 application is going to join, only the data that should be in Potter 4 application will move around. So we will have this when it joins, and when there is a scale down, only this data is going to get split to the nodes that should be the owner with 3 nodes. So here with 4 nodes, these 2 are this is the configuration. So why is this important? This is very important because when we are doing a scale down and a scale up and we have millions of data in our memory, reshuffling all the data around the network can be a big mess, right? So if you want your cluster to be stable, as much as stable, having consistent hashing algorithms or products that implement consistent hashing algorithms, it's very, very important. And that's thanks of JGroups, that it's like the Dumbledore of Infinispan. I'm going to drink a little. So Dumbledore JGroups, it's a library for doing TCP reliable communication in Java. And Infinispan uses this to communicate the nodes. And all the algorithm of consistent hashing and all the different features that Infinispan does are implemented in Infinispan, but connectivity and connection is done with JGroups. So what which frameworks we can use Infinispan? With which frameworks? I'm sorry, I'm always doing French speaking and Spanish speaking, not much English speaking, so I'm sorry if maybe I'm using French words sometimes, I excuse myself. So Hibernate, Apache Camel, Keycloak, Spark, we are doing integrations with all those frameworks. With Infinispan Spring Boot, I've been working on that for the last 6 months, and we are actively maintaining that. So we are using, Infinispan can implement JCAS, CDI, JPA. We can do persistence in different levels with JPA if we want, with RocksDB, and we can do even in-memory transactions if we need. So, or transactions, not just in memory, just transactions. So that's a very big stack to supply lots of functionality in your applications. So who is familiar with Vertex here? So Vertex is just for a very quick, for those who don't know, it's a toolkit to develop applications on top of the JVM applications or microservices if we want, because it's a very lightweight, polyglot, and it's like the Node.js style, having an event loop and the reactor pattern. So we will have verticals that are like applications instance, where we will have different handlers that will check about event loops, and the event loop, the handlers will listen to the events, treat the event, and so on, like Node.js. And there is a functionality called the event bus, and the event bus allows to send, doing publish-subscriber communication between verticals. And we can put this event bus in cluster mode, so we can have different verticals joining in a same cluster, so they will communicate with the event bus. And now, so I'm going to show you a little example. Before that. So I'm going just to explain what I've done. So I've done a little application, which is the Voldemort Taboo course. So for those who are familiar with Harry Potter will know, and for the others I explain. In the films and in the books, people are always saying, he who must not be named, you know who, and all that, and you are like, when you're listening to them, you're like, but what's going on? Why they cannot say Voldemort? I don't know. Are they crazy or what? What's these paranoid people, right? And the thing is that what we know in the end is that there is a curse on the name, and they are not dumb. They are protecting themselves. So the idea is that when someone says Voldemort, an editor can automatically point there and kill him. So everybody's avoiding to say Voldemort. So in this application, what I've done is creating a vertical in Vertex that will, in a cluster, that will send message to the event bus to say, this wizard has said Voldemort. So there is another vertical that will consume messages from the event bus, and whenever it gets the name of a wizard, it's going to send a message to the Adavacadabra address to say, I'm starting to kill this wizard, and when it's over, it's going to send another message to say, I'm over of killing this wizard. And in the end, the Dark Lord, it's only going to monitor what's going on to see which the editor is killing which wizard. So it's clear enough? Yeah, are you with me? Okay, so I'm going to do a little demo here about that. I'm going to put the presenter mode. So, up. So here I have, so the wizard. This is very simple code. So we have public class wizard which extends abstract vertical, and that's enough. I'm going to just open it like that. And what I'm doing to start a vertex in cluster mode, we can just use vertex.clusteredVertex, and then we are going to deploy the vertical. And the vertical, what it's doing here, I forgot to say just before, vertex in the foundations, it's been think as a completely asynchronous and reactive framework. So everything is asynchronous and reactive programming. So here, I'm getting the start future, and what I'm doing is periodically, so every second, getting a random wizard and sending to the named address in the event bus, which is the wizard who is saying Voldemort. So I'm going to start this application. And so here we say Ron Weasley has said Voldemort, Hermione has twice Voldemort, and so on. So the editor is it's going to consume messages from the event bus here in the named address, going to pick up the name of the wizard, and it's going to cast this wizard. So the code basically does, if I'm not casting a wizard already, I'm casting a wizard, I send a message, I'm casting. After 3 seconds, I'm over, and casting is over. So, and the Dark Lord here, so it's starting. The Dark Lord is just consuming addresses, consuming messages from a Dabakadabra address and logging stuff. So those are communicating with a clustered event bus in my machine, but it can be in different JVMs. So what happens if I start a second editor? Oh, sorry, I'm here. So I'm starting a second editor here. So the consuming messages from the event bus is going to be balanced between both the editors. But when I look to the Dark Lord here, I'm going to start to see these alerts saying, hey, editor 2 started to cast Hermione, but it's been already casted at this very moment by the editor number 1. And that's a problem, because if 2 editors point to the same person, maybe they will kill each other. So we don't want this to happen. So I'm going to just kill everything up. No, here, sorry. Up, everything is gone. So with Vertex here, I can use in the editors, sorry, here. What I can do is, okay, I want to synchronize this code. I don't want 2 editors to work on this on the same time. So I can do Vertex get share data, and I can acquire a log. And here I have the asynchronous result. If asynchronous result succeed, I'm doing something else. I'm going to log asynchronous result failed. So I'm going to pick up all this code here. I'm going to put it here. So if I succeed, it means I acquired a log. Here. So I'm going to release the log here. So I'm synchronizing the code here. And if I start everything back again, with a second, so wizard, the editor, the Dark Lord. So the editors started, 1, 2, the dark log is here, and the wizards are there. And we can stay long enough to see that we won't have any alert anymore. One wizard is going to do, this is synchronized. So that's good for me for this demo. I'm not going to stay here all the morning to check that they are not going to kill each other. And I'm not an editor, so I don't care. So if they kill each other. So here up. I'm sorry, here. Just going to kill everything. So I'm coming back to my presentation. Yeah, maybe you are like, okay, what's the point of all this? So first point is, yeah, Vertex exists, so you can use it for developing really asynchronous services and applications, and it can be in cluster mode. Clustering, it's done by Infinispan. So what Vertex Cluster Manager is using underneath is Infinispan to connect, Infinispan to communicate and connect and put this event bus in cluster mode. So what have we used here? We've used Infinispan library mode with Vertex integration. And what you've seen, I'm using vertex.getShareData.getLog. This log that's the Vertex API, but underneath what it's using is clusters log API, which is like it's a distributed log, not for synchronizing work between threads, but between instances of Infinispan. And it's completely asynchronous. And the interface looks like a regular Java log. And what is interesting of this is that I've coded this API and the implementation of this log using available Infinispan APIs. So I didn't invent something really crazy to do it. I used listeners, I used different APIs that are already available and you can use to develop really, give solutions for many, many, many use cases. And I'm not saying, yes, use this log, use a log, it's not the point. It's just something to show that we can go to do these kind of things, and it's very powerful. But I think you have to think is that when you are embedding data this way in your applications, you are going stateful. So when you are taking Infinispan or whatever other memory data and embedding it, you are stateful. And we are told we have to do stateless applications, right? But stateless applications don't do much if there is no state. So what do we want? We want stateless applications, stateful applications, but we want them stateless. And there we come with the stateless application microservices and containers. So if I have stateless microservices, how can I achieve this magic state? Because state already exists in stateful applications. It's just not embedded on your application, it's somewhere else. So how can we be really performant and really fast? So we can use Infinispan in client-server mode. So from one side, we will have different microservices where we are going to use an Infinispan client, and it can be a Node.js microservice, Java or JDK microservice, C# microservice, different languages supported. And using an Infinispan client, it will connect to a cluster somewhere. So it can be in a deployment, in whatever you are going to deploy the cluster. Why is this nice? One of the biggest features we have with Infinispan is that when, for example, in production, we can imagine having 2 data centers. So with a load balancer in the front, where we will have different microservices deployed in each of them, but we're going to balance data. So one of the data centers is going to treat young wizards, and the other is going to treat old wizards. And we will have an Infinispan cluster with a distributed cache with 3, 4 owners, whatever we need for our consistency. And yeah, data is going to be separated, but they are going to communicate it to each other and back up the data in the other data center. And that's very interesting because if I lose one of the data centers, and you will, but that, or something, if you lose something like that, and that will happen maybe one day, we can rebalance all the young wizards to the data center number 2 and use the backup data the time we restore data center number 1. And that's done with the cross-site replication. JGroup supports cross-site replication across different data centers, and we might even have different Infinispan clusters in each of them. I mean, we can have in the Darmstrang data center spells and muggles, here just spells with 3 nodes, and in Hogwarts just spells with 4 nodes. And the data will be backed up using JGroups and the Relay 2 protocol. Okay. So, is it fine? Are you with me still? Yes? What I just maybe forgot to say, when we are in client-server mode or embedded mode, we almost have the same functionalities. For example, we can do transactions on client-server mode, but we can't use logs in client-server mode because they aren't yet implemented. But it's not because we can't do it. It's just, it doesn't exist. But all of what I have explained in embedded mode about replicated caches, distributed caches, consistent hashing, and all that, it applies to server mode too. I mean, it's the same. So for a while, in years from now, we were in these JVM frameworks, different wars, and there were so many JVM frameworks. And for a moment, I think we were done. I mean, it was like a bit calm in the back end, and it was more front-end people fighting to each other or which JavaScript framework is better. But now there's fantastic bits that it's coming back with the JVM, and there are so many new frameworks emerging right now. So there is Micronaut that I discovered yesterday, and I'm amazed by this framework. It's really good. And there is Quarkus. Who knows Quarkus or has listened about Quarkus so far? Yeah, so Quarkus is being released in version 11. Now it's in version 0.12. I mean, it's not an stable version yet, about 3 weeks ago, so it's really new. And so Quarkus is a supersonic subatomic Java. That's the website. But it's built with the idea of having Kubernetes native Java stack for GraalVM and OpenJDK, and built on the best libraries and standards. So which are these libraries? Infinispan in client mode is there. So we can use Vertex, Hibernate, REST-DC, PachiCamel, and lots of them. And it means that these frameworks work on native mode now, on GraalVM. Why is this important? We see here, it's something I extracted. It's a very short thing that I'm going to say. We've seen that in a traditional cloud with a REST web service, we can have 140 megabytes. Quarkus and OpenJDK, it's 74. And using it with GraalVM and native mode, we go to 13 megabytes. And why is this important? That's important because the size matters on containers and serverless architectures and function as a service and all that. And because size matters, we are seeing that there are people considering, even if they love Java and JVM stack, they are considering using Go or Node.js for function as a service instead of Java just for this. And so it's very important to go there, and we are coming. So I've built a little application, and that's the final part of my talk. And I built a little application on Quarkus, where I have like a little service there that it's just putting some data in an Infinispan cluster every 3 seconds, saying this wizard is casting this spell. So putting data. And so I have this Hogwarts magic WebSocket that is doing a continuous query to the Infinispan server cluster. And I want to see who is doing magic continuously. But I just want to know those characters that are potentially at Hogwarts. So it's teachers and students, but not the editors, for example. So I'm just going to monitor that, and I'm going to open a WebSocket in a browser, and I'm going to check that. So I'm coming to my second here. Okay. So first thing here is, so this is like a little normal application for a test that I've been working on. What is nice about Quarkus is that it doesn't feel very new. It feels like something you are used to work with. So I mean injection, I mean services like we were used to coding in Java. So for example, I have this, I'm going to just run. So to run Quarkus here, I do Quarkus dev. And I'm starting, and I have an Infinispan server running. So it's just a cluster of one. And here things are working, and I'm putting data on the Infinispan. And if I go to localhost, so this is my application, and for now this is not working, the monitoring. It says nobody is executing nothing because I didn't do the code. But I can see I have some data here, so I have these characters, they're different characters, and I can do a search term by biography and name. For example, if I put here is Cho Chang or Charlie Weasley. So these queries, this full text query is done upon Infinispan. Infinispan supports full text queries. So that's something. But what I want to do is having a continuous query here and a WebSocket, because the WebSocket is here, but I just sent a message. So what I'm going to do, this is the WebSocket. So to create a WebSocket, I'm just going to create, this is an application scope. So you see this is the standard annotations. I'm going to say the server point is Harry Potter or Hogwarts. And I'm going to inject the database where I'm putting data constantly now. And I'm using inject annotation and remote to say the name of the Infinispan cache is HP magic name. And so I have these methods here on open, so that's executed when I open a WebSocket. So it's here where the message we see now, it's nobody executed nothing. That's the message I send. So I'm going to create a continuous query here with the Infinispan client. So first thing I'm going to do is create a query for here with the query factory. Here I'm just saying, give me all of them. Give me all, everything. I'm going to just look after to this. I'm going to create a continuous query here with the continuous query, and I'm going to link this continuous query to the query and the listener. This is something that is happening in your application locally. So the listener here, I'm going to implement result joining. So this is going to get executed every time I get a new value in the Infinispan cache. And instead of, I'm going to put this here. So instead of saying nobody executed nothing, I'm going to pick up value get wizard, caster, and value get spell. And now I'm going to just call refresh here and check, and it's starting to get, yeah, and if you, I didn't restart the application because hot reload works, which is amazing for us on the JVM ecosystem today. But here what I'm doing is that I'm having everybody, so I just want some of the wizards. So I want those who are in Hogwarts now. So I can say, okay, those in Hogwarts having Hogwarts true. And I come here and I refresh, and I will only, so here I just display one, and if I'm looking, sorry, here, sorry for the, in the terminal, there are people here being added in the database, in the Infinispan cache, but I'm not getting everybody because there is this filter. So that's my Quarkus demo so far. From a coding point of view. But so what is cool from Quarkus is that you can run this, you can create a native executable. So this gets about 1 minute, more than 1 minute to build. So I have it already here. I have this Harry Potter Quarkus runner, which is a native executable. So I have this run. And yeah, it started super fast, and it's just working there. Well, it's the same application. Did you follow? Any questions so far? No? So here, just to be fast, just to finish, 5 minutes. So I've created a native executable for Mac, but you can create one for Docker. So instead of to create a native executable, you just need to run, in this example, Maven clean package with profile native. And if you want it to run in a Docker container, you will say native image Docker build true. So I've done this, and you can grab here, I have this container already there, and because this presentation is shorter, I don't have time to show it running on Kubernetes Openshift. I don't have enough time to show that, but you can use this native image or fork my project or launch my project, and you will be able to play and test how it behaves on Docker containers. Because the Docker container, so if we grab a look to the Docker file, is from CentOS, and I'm just copying the runner, the executable, copying the two data sets that I'm using in this demo to have data, and then that's all. So now I'm over with this. This is what we've been using there. So the hot rod client with Quarkus integration. The embedded mode doesn't work on native mode still, but it probably will. So what you've seen is this. Infinispan has 10 years now, and it's used like for caching and for datagrid or key value store, like a NoSQL key value store with search, with many other functionalities. And what happens is that when you build things, sometimes the APIs are harder to understand, and that's why, because we need caches to be useful with and without search, that the API is a bit verbose today. So what we are working on Infinispan 10 is on a new API. I'm going to highlight that we will have something like an Infinispan client, new APIs like key value store, and will be completely reactive and asynchronous by default, so using completion stage. Today you can, caches interfaces are asynchronous and synchronous, but even if Infinispan inside is reactive, because we are non-blocking, we haven't still a fancy reactive API, and that's where I'm working on. So for example, for continuous query, we will have something like a store, find continuously, then I will do my query with a query language we have, put in the parameter, and then I will subscribe using any subscriber or Eric's Java or whatever, and then I can just work like on a reactive way. That's something we are working on just now. So the GitHub project, we are in Zulip to speak, Twitter, Stack Overflow, well, here is everything. The best way to start with Infinispan is going to GitHub, and there is a link there to the simple tutorials. And yeah, if you have any questions, this is the URL for feedback, I guess. It's this one. Yeah, okay.
Evaluate the talk.
Yeah, evaluate the talk. Please be kind. And yeah, eskerrik asko, because I'm Basque. I'm coming from Basque country, so we say eskerrik asko, gracias, thank you, and thanks for listening.